Hey everybody, Mrs. Bodechon here. Today we are going to be looking at 10B in our AKS portfolio. It says I can develop and use models to illustrate and explain the conventional flow, direct and alternating of current and the flow of electrons in simple series and parallel circuits. So there's a lot going on in this AKS. So let's start going through it. The first one is direct and alternating current. So I want you to think of a wire and the electrons flowing. You're asked to put these into a T-chart. So I made you a T-chart and we're going to discuss each one. Direct current means that all of your current is going to flow in one direction in the wire itself, okay? It cannot travel a very long distance. So these are going to be for places that are within close proximity, right? And they're usually provided by a battery source. Alternating current, on the other hand, the electrons inside the wire will go forwards, then backwards, forwards, then backwards, forwards, then backwards. So they alternate directions as they flow. Because of this, they can travel very long distances. Okay, so this is what we use for our electricity, for our schools and buildings and homes and whatnot. And those big power lines you see outside, those are alternating currents, and that's how we can send electricity from one side of the country to the other. They are provided by the outlet in your home or school or by a generator, okay? Then you're asked to make a Venn diagram on series and parallel circuits with all of this information, but we need to learn this information first. So let's take a look at it. So here you are given two examples of a series and a parallel circuit. A series circuit, you can either draw it or you can have a picture of what the circuit looks like itself. But a series circuit is a circuit in which you have a power source, a load, wires connecting, right? Same thing with a parallel, a power source, a load, and wires connecting. The difference between them is how many branches they have, or pathways, okay? So you can see we always go from negative to positive on our battery for the flow of current. So negative around to positive, I have one pathway there. So a series, and if you look at the drawing, you start here, you go around, and there's one pathway there for my electrons to flow through. That's what makes it a series. Parallel, on the other hand, I have at least two or more pathways that my electrons can follow. So if I start at my negative, which is my little end here on my battery, and I go around, well, that's one pathway to make it back to my battery, but I can go a second pathway as well to make it back to my battery. So two pathways or more makes it parallel. Same thing here. I can go around one, or I can go two, right there. So that's the difference, series and parallel basics. Let's talk a little bit more in depth now. Here, I'll cover up parallel and we'll just talk series first. So we're going to talk about how we measure current now in a series circuit because they are different, okay? So current is the same at all points in the circuit. And I can measure the current with an ammeter or a multimeter, you guys. There's like a little handheld device and you can put the prongs right on top of the wire and you can take the reading, okay? So if I were to do that and I were to take a reading right here on my circuit, I would have 2 amps, and everywhere else I would also have 2 amps. It doesn't matter where I take the reading. In a series circuit, it's the same all over the entire circuit. On parallel, the other hand, it's totally different, okay? If I take the reading before my wire branches out, so you can see it's right here after the battery, it says 2 amps. But what's going to happen when I reach that branch is it's going to be divided by however many branches there are. So I have one pathway, two pathway, so I am going to divide my number by 2. I have 2 amps, so divided by 2 gives me 1, and it's going to be split equally across those branches. So this branchway has 1 amp, and this pathway has 1 amp as well for each of these light bulbs. The thing is, when my pathways merge back together, those amps are going to add back up. So afterwards, you can see I now have 2 amps again. So that is the cool thing about a parallel circuit. If we're looking at how we measure voltage in a series circuit only, you can see the series is shared between components. I'm sorry, the voltage is shared between components. So our battery here has 3 volts. And you guys have seen the voltage on batteries. We're like, oh, I have a 9-volt battery or whatever. Well, this is a 3-volt battery. Notice I'm taking the reading on either side of the battery itself to get those 3 volts. And you can do this with a voltmeter or a multimeter in order to take that reading. And then as we go along, we can see our components. The component right here is a light bulb. So if I were to take the reading on either side of that light bulb, because I have 2 light bulbs, I'm going to divide that number by 2. So I had a total of 3. They are sharing equally, so it's going to be 1.5 each. Now, if I had 3 light bulbs, I would divide that number by 3, and then I would have 1 volt each, if that makes sense. Looking at a parallel circuit, the voltage is the same in all parts of the circuit, which makes a parallel circuit really awesome. Okay, so if I have 3 volts in my battery, everywhere I have 3 volts, which allows my components to shine at their full brightness. So these light bulbs will be shining at their full brightness all the time, as long as that battery still had power, right? Going back to my series, if my circuit was closed, well, my light bulbs would not be shining at their full brightness, okay? They would be dimmed because I would not be receiving those full 3 volts. I would only be receiving half because I about resistance. So if you see this, this is a series circuit and it's kind of just representing a wire here, and these are like the flow of electrons. It's really like a road with cars, right? And these are like toll booths that slow down the cars. In other words, it's slowing down the flow of current in our wire. And these toll booths are kind of like resistors, all right? So in a series circuit, if we add a resistor, we slow down traffic flow. The more we add, notice there's 3 resistors now, the more current flow, it comes to a halt, okay? So it's dramatically decreasing current flow. The opposite is true for a parallel circuit, all right? The more pathways we have, and the more that we increase our loads, the faster our current is allowed to flow. See how these cars are able to get through these tolls and go through very quickly. So that is a difference there with resistance. If we're looking at our Venn diagram, I'm going to quickly go through this. You can pause it and look at this more in depth, okay? So series circuit, it does have one pathway. It is the same current everywhere. Resistance increases with new loads, which means it holds back that current flow. If one bulb goes out, they all go out. And that is true, you guys. So if you break a bulb, if you untwist a bulb and the bulb comes out, whatever, it's loose, all the other bulbs will go out. This is why we don't use series circuits in our homes, because if we did, if we turned off the light switch in our kitchen, all the lights would go out in our whole house. The refrigerator would stop working. The TV would go off. I mean, it would be terrible. We don't want our house strung in series because then everything's on or everything's off all at the same time. That's not cool. The brightness will dim in a series circuit with new loads added. So like if you add more light bulbs, they'll all be dimmer. It uses less energy, which is true in this case with simple circuits. We're talking about battery life, right? So it's going to keep that battery for a lot longer, but your light bulbs will not be as bright, okay? And then moving over to parallel. Parallel has multiple pathways, which just means 2 or more. The current splits and then it adds up again after the branch, right? Resistance decreases with new loads. In other words, the current can flow faster. If one light bulb goes out, the others are not affected at all. So I can unscrew one and you can see all the other light bulbs on the other branches. They'll stay lit and they'll stay lit just as much as they were with that light bulb screwed in as it was screwed out, okay? And parallel is what we use in our homes, you guys. So we can turn off one thing and the other thing can be turned off because it's all in parallel, okay? It does not affect one another. The brightness won't change with a new load. So I can continually add a new load on a new branch and the brightness will not be affecting the others at all Because of this, it uses much more energy from our power source. In this case, we're talking batteries, right? So we're going to use up those batteries a lot faster. All right, and then the things that they have in common, the higher the voltage causes a higher current. It converts electrical energy into thermal energy. Those are all the same. Right here, you had to identify which one's series and which one's parallel. Hopefully at this point, it's easy for you, right? You can see that this one here, going from negative, I can go across and around, that's 1. And I can go all the way around, and that's 2. And this one, I only have the option to take the one pathway as series. Right here, you are asked to draw some circuits using 3 light bulbs, 2 batteries, 1 resistor, and the electricity must be flowing. In other words, it must be closed. So all the wires must be touching each other and attached, right? There should be no openings or gaps in our circuit. Here are some examples of the symbols that you use when drawing a circuit. You guys, I drew my circuits and I'm terrible at drawing with a mouse, so forgive my childish drawing here. You can see that I have my batteries. Remember, the little lines are negative and the bigger lines are going to be positive. So if I'm flowing around, I have one pathway making this series. These are circles with X's in them, if you didn't know, because it looks terrible, but that's all right. Those are my light bulbs, so I have 1, 2, 3, and here is my resistor, which is simply a zigzag line. Again, looks horrible, but you get the picture, right? Notice there are no gaps in my circuit, so electricity is flowing. Here is my next one, which is a parallel circuit. You can tell that because if I go from negative around to positive, that's 1, and then I have 2. So I have at least 2 branches going on. I have 1, 2, 3 of my light bulbs, and my crazy looking resistor is over here. Again, everything is closed, so my electricity is flowing. All right, this one tells you to identify the type of circuit and then draw some arrows based on the current flow. So I went ahead and did that for you. Hopefully you could tell that this one has multiple pathways, so it is parallel, as well as this one. This one, on the other hand, is series. It only has one pathway to follow. Now you have 2 different arrows you had to put on each one. You first had to draw a red arrow to show the conventional current flow in each circuit. Conventional means positive around to negative. So you'll see each one, the positive being the longer line, has a red arrow around, and red arrow around. And then you'll see that the blue arrow represents the electron flow, which is the actual way the electrons flow in a circuit. This is the one we're going to be talking about more, okay? And that's always from negative to positive. So look at those blue arrows, negative to positive, right? Negative to positive. Notice it's not always red on top, blue on the bottom. It depends on which way your battery is, because literally you're looking at your battery. Okay, so negative to positive is our electron flow. And that concludes 10B, guys. If you have any questions, let me know.